Hi students, we are currently learning a lot about Connecticut geology, and in order to fully tell that story, we need to talk about subduction with ocean crust going beneath other crust, and we need to talk about continental collision where continental crust butts up against other continental crust. We actually can make a visual model of these events using some pretty basic food items. This is a classic lab activity that a lot of earth science teachers use. This one is modified to make it a little more thorough, though, than what students typically do. In a normal school year, we would have this out and you all would do this at your stations, at your desks, but we can't really do that this year because of COVID. So I'm gonna show you my video and then you can take it and go with it from there. All right, so in this model, we have graham crackers on the bottom there that represent sea crust, or the denser part of our Earth's crust. And then we have some frosting, because we're gonna use the frosting as a model for the surface of the seafloor. Okay, so you have to try to realize that, imagine here we have an ocean. And so the frosting represents the sediment on the bottom of the seafloor. And then the graham cracker just represents, the crust itself. The Rice Krispie treat represents continental crust. And then I have M&Ms on top just to represent higher elevations of the continental crust and sediment as well. All right, so we learned so far that there was a stage in time going back about 500 million years ago. Okay, that's where we are. Baltica started to shift and move back towards Laurentia. Okay, Laurentia is of course proto-North America, and Baltica is a landmass that now includes a lot of Europe. About 500 million years ago, the convection currents that existed beneath the crust switched directions and started to cause Baltica to go back towards Laurentia. Okay? And when that happened, that would mean that you must have ocean crust caught in the middle. And that means you're going to get a subduction zone to form. And there's evidence that tells us that when this happened, it was actually the Laurentian seafloor that went beneath the other. Okay, so I'm gonna represent that here, okay? So we have the beginnings of a subduction zone where you have some ocean crust going beneath other ocean crust. Okay, hopefully that's pretty clear. Now, when this happens, I want you to watch closely right here, okay? And by the way, I should say that during all of this time, there's naturally going to be erosion at the surface. There's wind, there are rivers, there's gravity. And so over time, sediment from the mountains, the highlands of the continents, are going to be weathered and eroded and carried down and deposited offshore onto the onto the seafloor below. Seafloors are great places for deposition to occur. Mountains are great places for erosion to occur. Ocean seafloor it's great places where sediment can accumulate and deposit. All right. The slow ongoing movement of these pieces of crust would mean that not only and you can see that I'm struggling here a little bit, I'm breaking the cracker, but that's, pretty typical. Not only are we having a situation here now where, because of the diving crust, there's going to be mechanisms in place that melt that crust and create underground magma chambers, right? And if those magma chambers are if they contain enough pressure, the lava inside of them can cut its way all the way to the surface. And if that happens, you start getting these underwater seamounts, right? Which I'm gonna represent here with Hershey kisses, right? These are volcanic mountains that form on the seafloor. They can and often do grow tall enough so that the peaks of them emerge from the seafloor, emerge from the ocean surface, I mean. Okay, and then we would call them volcanic arc islands. And remember, volcanic arc islands, or the volcanic seamounts for that matter, they're always going to appear on the overriding crust, because the crust that is subducting beneath undergoes a lot of melting. So does maybe some of the base of the seafloor that's going over on top. So there's going to be some melting in there, and that molten rock, then being that it's more buoyant, tends to cut through the overriding crust, and that's why you get the volcanoes on the overriding crust. That's really important. And you might remember, we call them volcanic arc islands because if we look at them from above, they form in this arc shape, okay? Sometimes they grow, the islands themselves have so much activity, they grow so large that they merge and become one landmass. That's kind of like what happened to Japan, right? And that might very well have happened to the tectonic volcanoes that we talk about from this time period. So the volcanic islands that form in this subduction event are called the tectonic volcanic islands. Okay, now look what else is happening though. Let me bring this in closer. You might realize here that as that overriding crust is pushing, it is plowing and scraping seafloor sediment, and so you get this accretionary accretionary wedge that builds up in front of that overriding crust. That's kind of important because for Connecticut, we learned that sediment eventually is plowed up onto North America and helps build up what we now call Connecticut. That's why we wanted to bring that up. Okay, so let's continue to merge these two land masses together. Right, you get further and further melting. Those volcanic mountains can grow even further or grow even taller, right? And so here's a diagram that shows what I'm showing you here, right? So there is, this is reversed around though, because over here, this would represent Laurentia because it's the Laurentian sea crust that goes below the Baltica sea crust, okay? But there is that same accretionary wedge that we talk about. There's all that sediment that's being scraped as that diving seafloor goes underneath, but it's also mixed with sediment from the erosion of those rocks, okay? All right. Now we think it was around, let's say, 450 million years ago, where we finally get a situation where the volcanoes themselves are plowed up and pushed onto the crust of Laurentia, right? At this point, they would be so metamorphosized that they wouldn't even look like volcanoes anymore. The igneous rock that composed those volcanoes would have been metamorphosized and altered and fused onto Proto-North America or Laurentia to help start to build up what we call Connecticut, right? But this eventually does mean that as that seafloor continues to get consumed, that does mean that eventually these continents are going to meet. So we do think that Baltica and Laurentia do come together, okay? It wasn't until about 432 million years ago that the volcanoes themselves were thrust up and all that ocean sediment was thrust up onto North America to help build up Connecticut, okay? But it ultimately means that Baltica and Laurentia will make contact like I have here. And when that happens, there's no reason to believe that the convection currents beneath would change direction. So in other words, the convection currents beneath are still pushing Baltica in this direction and Laurentia in the opposite. So that means we're going to get continental collision here, right? And as those land masses push together, look what's happening to those Rice Krispie treats. They are being forcefully driven upwards. The crust is folded, okay? And so you get these giant folded mountains. These are non-volcanic at this point, okay? The volcanoes form earlier when the subduction is still out in the ocean. But once these continents make contact with one another, there's no more subduction that takes place. So any magma that is in magma chambers at this point will probably slowly cool into igneous rock and then metamorphosized as these land masses push together. But this process went on for a while, and these tectonic, well, actually this was called the Acadian Mountain event. Okay, so the mountains that formed at this collision were called the Acadian Mountains. And we don't really have too much of them left anymore. They were mostly eroded away. And then other mountain events later on in Connecticut's history really sort of deformed the crust even more and made the Acadian Mountains things of the past. So we don't walk around today finding Acadian Mountains here in Connecticut still, or anywhere in New England for that matter. All right, I hope this helped a little bit. And you are welcome to try this on your own and try to shoot your own film. If you do, I encourage you to make notes first and have the notes to read as you go, because there's a lot to think about.